John and Robert's math tutorial. Before we begin, let us recall the different types of functions. In order to determine what type of function each of these are, we must look at the degree of each term. Any number without a variable is a 0-degree term. Any number with the imaginary 1 here is a constant term. Any number with a squared is a quadratic term. In order to determine what type of overall function each of these are, we look at the greatest degree. So, because the greatest degree of a term here is 0, this is a constant function. Because the greatest degree of any term here is 1, this is a linear function. And because the greatest degree of any term here is 2, this is a quadratic function. Now, let us look at the task at hand. Suppose we are given to solve the problem x squared minus 9x minus 11 equals 0. Audience, tell me whether this is a constant equation, a linear equation, or a quadratic equation. If you said quadratic, you're right, because there is a square here, which means that this is a quadratic equation. Now, there are 4 ways to solve a quadratic equation. We can graph, factor, complete the square, or use the quadratic formula. Now, if we were to factor this, it would be very difficult because 11 times 1 has no factors that add up to 9. I also don't have any graph paper, so I'm not going to graph, and completing the square just sounds really overwhelming. And I love to sing, so let's sing a song. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Now, we can use this formula to solve this equation. But the question then comes up, what is a, b, and c? Going back to our constant linear and quadratic functions, a is going to be the coefficient of the quadratic term. B is going to be the coefficient of the linear term. And c is going to be the coefficient of the constant term. Now, let us go back to our original problem. X squared minus 9x minus 11 equals 0. We know this is a quadratic because the greatest degree of each term is squared. Now, let's define our variables. A, b, and c. A equals the coefficient of the quadratic term, 1. B equals the coefficient of the linear term, b equals negative 9. C equals the coefficient of the constant term, negative 11. Now we plug it into our quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, x equals 9 plus or minus the square root of 81 minus 4 times 11 is 44. So, and there are 2 negatives, so plus all over 2 times a, which is 2. 125. Although it's not a perfect square, 25 goes into this 5 times. So we can change root 125 into 5 root 5. So our final answer is x equals 9 plus or minus 5 root 5 all over 2. There will be some problems in this section that ask you for the nature of the roots. In order to find the nature of the roots, we must solve for the discriminant. The discriminant is equal to b squared minus 4ac. If the discriminant is equal to 0, there is one real root. If the discriminant is a negative number, then there will be 2 imaginary roots. If the discriminant is positive and it is a perfect square, there will be 2 real rational roots. And if it is not a perfect square, there will be 2 real irrational roots. Now, I will give you a couple of minutes to solve for b squared minus 4ac in these 4 problems. Please stop the video. Welcome back. Hopefully, these were the answers you got when you solved for b squared minus 4ac. Because this is 0, there will be 1 real root for this equation. Because this is negative, there will be 2 imaginary roots for this equation. Because this is a positive number and it is a perfect square, there will be 2 real rational roots. And because this is positive but it is not a perfect square, there will be 2 real imaginary roots for this equation. When solving for b squared minus 4ac, you just use the quadratic formula. Thanks for solving with us today. This was John and Robert's tutorial. Thanks for stopping by.